Okay, so so I'm going to talk a little bit, some topic. For example, today I'm going to talk about small program submissions. I'm going to show you a demo, how do you use it, because I see two students already submit homework assignment number 2, part 1, that you already obtained the virtual student ID. So you can start working on this part. And Friday, I'm going to start talking about final project. And also I'm going to prepare to release the specification for homework assignment number 3, which homework number 3 is going to be a major one. It's adding a few elements together. Especially this might be challenging for new object-oriented programmer. But it's really interesting. It motivates you to think programming differently, connecting more to the real world. It's actually connecting distributed system, JSON, and C++ all together. So I'm going to talk about that this Friday, that's coming in 2 days. And next Monday, I will be dedicated to homework 3, to tell you a few things that you need to learn to do that the homework. Okay, so that's my plan. So I'm going to talk about small program submission today. By the way, before I proceed, any question?
I had a question. By small program submissions, do you mean like homeworks 1 and 2 so far, or do you mean?
No, it's a different one.
Okay.
I briefly mentioned in one of the earlier class. So small program submission counts, if you look at the syllabus, counts 20%, which means that it is, I mean, we have homework, but each of the homework you can see, you actually, homework 1, homework 2, you probably don't feel it. But when you see homework 3 are kind of quite significant, that you have to bump to the wall a few times, not just a few times, probably for some of us. Average person probably need to bump a lot of time in order to get it to work. So a small program it's a very small program that you can actually get it from the textbook. And the thing is that the source code is available. I want you to just run it and get the result and submit it through a program. In fact, it's also the program similar to homework assignment number 1 that we will online check. So there is nobody to grade your homework but a program. If you submitted or the result generated incorrectly, it will tell you what went wrong, and then you have to figure out what's going on. So you need to do this a lot. This is encourage you to do more practice. I mean, the thing is that we just need to practice for you to write some program. In fact, this case, you are not really writing the program. You're kind of picking up a program example and at least try to understand it and try to compile it and then submit the result. So that's what we call, I will show you immediately what's going on, okay?
Thank you.
You're welcome. Yeah.
For homework 1, I tried to submit it using hand-in and I wasn't able to. There was an error.
Okay, that might be my problem. I haven't set up the submission side, because submission side, I need to put the entry there so you will be able to submit. I'll fix that after class. Thanks for letting me know. I thought, oh, the deadline is still a week from today or something like that, so I didn't pay attention to that. Yeah, thank you. I need to fix that today. All right. Any other question? I mean, I'm not going to spend the whole class talk about small program submission. The demo is going to be really short. And but after that, if you have any question regarding homework 1, homework 2, we can discuss. Okay, what I do want to mention before I move on to the small program. People ask me during my office hour or the other time, ask me whether the attendance of the class is required. So I basically say no. It's not required for you to. We don't take attendance essentially, and we record everything. So essentially, you don't have to come here and then just watch the video, but that to me is not the ideal environment for you to learn. as a community, as online. I really encourage you, instead of requiring you, I just want to, hopefully we can leverage the time in the class in a very useful, valuable way that you feel that attending class is a plus for you. One of the major advantage for you to attend the class is that when I'm talking about some concept, you can actually respond immediately. In fact, I kind of miss that class interaction when I have a pre-recorded video, because when I record a video, there's no student, no question that I cannot immediately respond. Similar for student, for all of you as well. If you have a question, it will be great if you bring up right at that moment. I mean, this will be totally appreciated. And that help you, help me, and help others as well. So I encourage you to participate because we have that more opportunity to do that. Okay, I know some of you are in different time zones, some of you are having other issue. I really encourage you, okay, and I don't require that. I just want to say that's my policy. Okay, all right, I'm going to talk about small program. Let me see, how do I end this? Oh, no, not this one. How do I get out of here? Okay, now I'm going to my window. Let me make it smaller. Okay, I assume you can all see my screen. I just want to show you what it looks like. Let's see, where's my server? Yeah, this is all my other project I'm developing. I thought I have a window already somewhere. Ah, here's a window. Is this already developed? Okay, great. Says, no, this is a client. I want to look for server. Ah, server is here. Okay, I'm going to run the, okay. So this is in fact, this is just to let you know that this machine is actually in Cyrus, our server. So I'm actually running a program called small program server, and I want you to connect to that. And just to let you know how many parameters you know roughly about on the server side, even though you don't need to worry about server side, but I think it's good for you to be aware what you're dealing with. So under here, I have all the program. I have all the program that's actually that I will release to you, say, hey, you should right now should focus on this program. So from your textbook, I select about 30 some program that for you to work out. And you can see that this if you look at this GitHub corresponding to the program that's actually, I gave it to you in the syllabus. This is from your textbooks, as you can remember, that we started with chapter 11. With chapter 11, that's why exercise 1101, exercise 1101A, and one after the other, okay? And so this is the focus. Currently, I set it up, the program to cover chapter 11 to chapter 14, which is the core part for ecs36b, okay? So that's a program that the server side, they try to probe this to you. Okay, so I'm gonna run the server, and I already put the server command, just make sure I test it before I come to the class. So you can see that I have a program, which is, I call it, the program name is called SP, Small Program Server Rewritten. And the name of the program, I mean, this can be anything. I just call it ecs36b for 2020 SP. And the port number is important, 9561602. I probably should publish this somewhere so you can always retrieve this information. And then it's actually picking up the master file, which is the same master file I use in the homework assignment number 1. And I have a log. And also, this is the most important. That's why I say you have to do homework assignment number part 2, because now I'm actually using the VSID from fall 2020. And earlier I checked, there are only 3 records. One is myself and 2 other students already done. I won't reveal who they are. And then this is the ECS programs and also some logs. So I'm running the server. I just restart the server. Okay, I'm running the server. This server will run 24/7. Hopefully it won't crash very often. Okay, so now I'm actually going to be on the client side. Okay, I need to do something before okay, I want to do this. I want to start it from the beginning. Sorry. I want to remove. You see that there is a progress because I already done some tests. By the way, this number 17744, that's my VSID, virtual student ID. If you look at this progress, it's tracking how much you have been working on this small program. So this basically say, oh, around, wow, the timestamp doesn't make sense. Yeah, timestamp doesn't make sense. I better just remove this. This might be better, not to confuse you. Okay, I remove. Everything is clean. There's nobody ever submit any program. So I'm going to run the program. So you're going to use a program. I will give you a program called SP Client. Okay, this is a program. If you say SP Client, it actually have a 2 way to use this program. One is say to request, and one is to submit. So requests basically say, hey, which program I haven't worked on, can you actually suggest a program to me so I can work on that? And the submit, basically, after you get the program, you see that the difference between the request and the submit, it's a submit, you actually say which URL you were working on and what's your output file. And then, so you submit the result and we'll see whether that's successful or not, okay? So let's actually try it out. So assuming I have to know first 169.237.6.102. That's the IP address, and the port number is 95602. And my VSID, I know is here. I just copy and paste. Okay, after I have that, wait a minute, connection failed. Why? Oh, because I killed the server. I haven't restarted the server. So now I have the server running. Now I actually run this again. So now you can see what happened is that I submit the action, is called program request from VSID. And then basically you return, receive another JSON saying that, okay, the next program is this particular URL. Is actually in chapter 11 ecs36b. Okay, let's just go there and check it out what they are. Okay, let me actually just copy and paste this to my Firefox. Oh no, I got copied too much. Did I copy too much? Let's see, what did I do? Okay, I copied too much. I just need to copy this part. So remember, it's a chapter 11. So I get to the source code, and I go to chapter 11, and then there is a ex1101 CPP. Okay, you see that? That's the program. So I'm going to download this program. Let me see. This is program. There's a way for me to save it. Where is that? Go to file. This must be here, right? Okay, forget it. I'll just copy it. I'll just simply copy it here. Okay, I will use a different window. Let me make a directory. Let me go to the ecs36b. I would say let's go to cd program. CD small program. Okay, assuming I actually work on it here. All right, I'm actually getting that program sorry, I should call it PEX11. Let me just call that program here, and then I will just, boom. Okay, I copy and paste that program over here. So this is a program that you don't really need to change anything. You just basically try to compile it. G++ minus std is equal to C++ 14 PEX11. Let's just do a default, because the default is going to be /a.out. Okay, so that is your output. Okay, so here is something important. You need to capture that output. So we're using what we call output redirection. This is a Unix command. The way output redirection is this greater than sign. If you put this greater than sign, I would say this is called ex11 F2020 output. Okay, so if you take a look at this file, you can see that the output, it was sent out through printf or fprintf. By the way, you should know that these two are exactly the same, just a little bit coaching moment for Unix, that if you do print f, whatever, this is equivalent to say fprint f std out something, okay? These two are exactly the same because std out is device 1. And then there's another one, which is 2, which is the std arrow. You can, for example, you're doing debugging, you can send your regular output to standard output. You can send your arrow message to standard ERR. So this is just output device. And we use fprintf a lot using printing to a file, for example, but you can also print it to this device. Okay, right now I have this this nice output with capture over here. So I'm going to do the submission. Okay, so I'm not going to submit over here. I'm going to do it here. Okay, I actually already done that earlier. So I'm going to show you what I did here. You see that I'm actually running this program, SP client, and with IP address, and with a port number, with my virtual student ID, and with the URL. This part is the URL exactly when I receive it earlier from the request, and then the output that I produce. So if I, let me actually tell you that something could go wrong. If I do a 2, okay, so this is a URL, but I'm actually sending a different output, then I will get, wait a minute, it says successful. That's weird. That's interesting. It shouldn't be match. Let me see if I do this. Interesting. But anyway, if you suppose, okay, you didn't see this. I don't know why. I have to check my program. Because suppose that if you submit the result is actually match with the expected result, you will get the successful. By the way, if I submit twice, it will say done already. So it means that I already done that program. So they don't want me to just repeat to stuck on one single program because my the progress has been tracked. Okay. But if you submit a result that's incorrect, it will tell you failed and result and tell you some reason for that. Okay, so after I done this, if you do this again, do this request again. If you do this, this is a request. It's actually giving you another program. Now it's actually asking you to do ex1101A, which is the next program. Okay, but since I'm actually on the same terminal, let me actually just switch over here. Okay, so I'm going to do more 1774. This is the progress that you can see that the progress has been adjusted, saying that, well, I have matched the output for that. Okay. So that's the program, what I call a small program. So it's essentially You use a program to contact the server to request a program, and you got that program from URL or whatever the local copy you have, and then you have to make sure you compile it correctly and run it, capture the output, and then you submit it to the server, and then the server will do the check whether your output is correct, okay? So that's what you need to do. You just need to, because you can see that I keep a file called progress for every single student. And therefore, if I be able to see that you accomplish more than 20 of them, then you will get the 20% from this class. Okay, this part is really just, it's not as tricky as the other part of the homework. It's straight from the book, and you just need to follow the protocol and you can get this 20%. But it's good for you to just practicing writing some small program like this, okay? Any question?
So you will give us that client file?
Yes, I will release that client program with, I think I have a small document to talk about how to do that. Yeah, you will have that client program.
Okay, thank you.
Yeah, in fact, your client program will be, in fact, pretty similar to your homework assignment number 1, actually. But it's a separate, I have to change something, yeah. Get that to work.
Are there due dates for each program?
Oh, okay, that's a great question. No deadline, you have to do it before the end of the quarter. You have to do that before the end of the quarter for that 20%. Before I turn in the grade, you have to get all this done. I don't put any deadline. However, for your advantage, that you might want to do it earlier. You might want to do it earlier. So follow the flow of the lecture and the topics we cover to help you. I mean, of course, that sometimes you're kind of distracted to other things. That's okay. So that's why we don't have a deadline for every single one. But at the end of the quarter, you should try to get at least 20. I mean, in fact, most of the students get 36, all 36. They got all of them, all the way to the end. But you need to get 20 in order to get that 20%.
Can we get help during the office hours for small programs as well?
Say that again.
Can we get support or help for the small programs?
Of course. Yeah, of course. Yeah, I mean, office hour and discussion are for everything. And sometimes we actually just, for example, last time when I had this, there was one program that's actually require a random number. And I didn't realize that when I first assigned that. So you can imagine that if you use random number, that the different student will generate different output. And therefore, it cannot be matched. So we actually realized it's kind of embarrassing on my side. It's that, oh, oops, I forgot to consider this randomness in the grading process. Yeah. So yeah, of course, you can ask any kind of question or help or support for small program. Yeah. Okay, any other question?
Professor,
could you publish? Oh, okay.
Go ahead, please.
Saki can go first.
Oh, thank you. Could you publish the document for small programs soon?
Yeah, I will do
Okay.
that. I will do that
Thank
soon
you.
together with the client program itself. Yeah.
Okay, thank you.
You're welcome.
So my question was just something I'm a little confused about. Like, I'm just confused about the fact that with what I've seen in lectures so far, I've seen very little of us actually doing like object-oriented programming, and I'm just confused like why we spend so little time in the actual IDE, and we haven't really written much in C++. It's mostly been Unix commands, so I'm just confused if I'm like there's something that I've missed some lectures, or I'm a little lost why so much of it is not in the IDE.
Okay. we're not going to talk a lot about IDE. IDE is just a environment for us to develop the program. The core is about both object-oriented programming and object-oriented modeling. In fact, there is an emphasis on both sides. One is linguistic perspective, means that, well, how do you specify a class? And how do you actually specify a inheritance relationship, for example? And those are specific to object-oriented programming. That's I consider is a linguistic perspective about the programming, which I start talking about that, I think from lecture number 3 or number 2, I forgot. Okay, I have to track my own lecture. So, so that's one perspective. But the other perspective, which is equally important, maybe even more important, is the modeling perspective. Is that when you have the concept about object-oriented, it's not really about which language you use. By the way, you can use C language. You can use even assembly language, something very low level, to implement the concept of object-oriented. So object-oriented programming has a concept is try to model the complex scenario you need to deal with. So we try to, in this course, we try to balance between these two. On one hand, you understand the linguistics about those object-oriented feature in this particular language called C++. But also it's important about, well, when you should use that. I mean, later in the lecture, I will actually even argue that some of the feature in C++ or in Java, they are potentially harmful if you use it incorrectly. So that's kind of the two sides. It's something which I'm just guessing where you're coming from, Mia, about your question. But I just wonder what other things maybe you are hoping to learn more, but you don't see that we're doing this right now. Mia, are you there? You mute yourself, Mia. Hello? Okay, it's probably internet problem. Sorry about that. Okay, any before Mia came back, any question?
Yeah.
But yeah, you.
No, you can go first. It's all good.
Okay, it's a really simple question. So will you make more new videos upon the new featured work? Like, cause some of your old lectures from spring are kind of different from ours.
Yes, I will make some video, which is try to fill the gap between some of the new topic, which I want to do that again, or some of the topic which I think I want to go a little bit deeper. Yes, I will do that. But also, I do want to say that that's why sometimes I want to use this class time, the Zoom video, to record a few things which might be interesting and useful for all of you. For example, yesterday during my office hour, some of you might have watched it. I actually I want to see how many people watched the video yesterday. Let me actually take a look. Let me refresh. Okay, so I have a 49 student watch yesterday's video, if you can take a look at this one. And this one, actually, I cover the error detection part for the MyHero program. I think that is I kind of leverage that opportunity to talk about that. But I do want to say that the information there might be really helpful for you to work on that project. So please check out here. Like I try to label it, for example, this lecture, let me see. I actually mostly talk about homework assignment number 2, part 1. And this one talk about homework assignment number 1, part 2. But this one particularly, I kind of highlighted to talk about the error detection. So I have this segment of topics, and sometime I will try to remind you through announcement about, oh, if you look at this topic, you might want to see here as well. Okay, so so those are the supplement to what is already have in the video. Okay, just for your information.
Professor, all of the videos, they're on your YouTube channel, right?
Yes, everything, whenever, including today. After I'm done, I'm actually just go through the YouTube publishing process to publish the video. Yeah,
Okay.
you can actually see that. It's kind of nice to see the Google Analytics about how people are, like which part of the lecture when they drop out and things like that.
And I had two questions.
Go ahead.
One was, so like I'm on Windows and I'm still stuck on a part 1 of homework 1, and like I understand conceptually what we're trying to do, but like I tried using the command prompt and like it's just like not going anywhere. So do you have like a recommendation for like what I should be using?
You're using WSL, right? You're using Windows, but with
The subsystem for Linux?
Yeah, WSL.
Okay, yeah. So
right.
someone on the Discord recommend that, so yeah, I'll
Right. No,
okay.
I will recommend that as well.
Okay.
I will recommend that as well.
Cool.
This is Arthur, right?
Yeah. Mm-hmm.
Okay, this is for everybody. Yesterday's video, I also recorded I helped one particular student to solve a problem regarding his Linux window and the window, the regular window file system. I mean, there are different kind of issue you will encounter if you have never done this before. I don't know whether, Arthur, you got stuck at exactly the same place, but that particular issue was that the student is using Linux on top of a window environment,
Mm-hmm.
and he is using his window to download the tar file. And he doesn't know how to go inside the Linux or inside WSL to obtain the file from the window partition.
Mm.
So that is very common because it's how do you actually get that file? So if you watch yesterday's video, I think it was recorded. What you need to do, let me actually write it down. You need to use a program called DF inside the Linux or inside WSL called DF. It's looking at your file system, how it's mounting. And in that particular student, that his C drive, so Windows is based on C drive, D drive.
Yeah.
The C drive was mounted under, I think, /MMT/C. If you check anything under /MMT/C, that's actually equivalent to the C drive. And then that's the kind of a hook for you to kind of get access to your window partition. So essentially your file system has one part, which is what we call the Linux partition, and the other part is a window partition. And that is something, that's a perfect question for you to ask, Arthur, because it really helps not just you, but other people share the same issue as well. But once you know how to do that, once you know how to use the command DF to actually figure that out, and then you will be able to handle any type of file system in the future. Essentially, you can work on lots of kind of different environment, not just the Windows or Linux environment alone. Okay.
Mm-hmm. Okay, thank you, Professor. And so yeah, I'll do my best to get done. Like, but if anything still comes up, could we schedule like office hours?
Sure. If you cannot make it to my office hour, we can do one-on-one, or we can just if people needs more office hour, we can do more office hour. No problem.
Okay, awesome. Thank you.
You're welcome. Okay, is there any other question? Is Mia back?
Oh, could I ask a question?
Sure, Ray. Go ahead.
Do you know if it's normal for, so I also got WSL, and then I got like a Linux distribution.
Mm-hmm.
Do you know if it's normal for the files of the Linux distribution to be stored under a hard disk image file?
Yeah, it's very normal.
Oh,
Yeah, it's very normal.
Okay,
Yeah,
so I just have to access the files through the terminal.
Yeah, you can do
Okay.
that. Yeah, you can access to that through the terminal. Yeah.
Okay, thank you.
Yeah. So I would suggest you to use if you WSL. I forgot whether I mentioned it's using Ubuntu 14 or 18. I forgot. That's a more stable version. So just let you know, Linux.
18. It's in the syllabus as well.
Right. Okay. Yeah. So if it's an even number, that means it's supposed to be more stable than the odd number. Okay.
Mm-hmm. Okay. Thank you.
You're welcome.
Sorry, Professor. Could you repeat that again? Like the one you recommended.
Let me actually check. I think I did. Let me hold on. Let me bring up my. I haven't touched that part of the world recently. Let me do that. 1 second. I want to just bring up my document. Yeah, I recommend Ubuntu 18.04 LTS. That's actually specified in the syllabus. That is a pretty stable version.
Wait, Ubuntu what?
Ubuntu 18. Let me show you my screen. Okay, hold on 1 second. Yeah, you can see my screen, right? So this part,
Yeah.
this is in I don't know which page. Page 6, the last page of the syllabus. I said here. If you don't know anything, just pick this one, Ubuntu 18.04 LTS.
Great, thank you.
Also, I just want to tell you that this is exactly the issue I deal with yesterday. Is a student after install, you have to do all this. I mean, one of the students just cannot get the G++ compiler to install. You have to do, number one, to do sudo apt-get update. This, you have to do it first, and then you do the next 6 to get your makefile G++ GCC installed correctly.
Okay. And is the syllabus, is it on the Facebook page or is it on Canvas?
I think I sent it through Canvas initially.
Okay.
And,
oh yeah, my bad. I see the link.
Okay.
Thank you.
And I also put it in the class folder. If you go to, let me see. I mean, everything I publish, I pretty much always put in Cyrus. Let me see, not this folder. This is a Spring folder. You can go there to check, but you can go to the fall folder. This is the fall folder that has everything there.
Mm-hmm. Okay. Thank you so much, Professor.
You're welcome.
Professor, I got a question.
Sure, go ahead.
Yeah, I got a question on homework 1, part 2.
Mm-hmm.
I am not quite sure which stuff we're supposed to turn in for two-handed. So you said we need a diff or original one and the heel one and the mismatch.
Okay, let's bring my homework assignment number 1. I thought I said you have to bring in all my break.c, my heel.c, as well as the I think you have to turn in a makefile. I do require you to turn in a makefile. Let me go bring up the spec, okay, and see if I make anything unclear there. Okay, let me share my screen. Okay, so this is the homework, and okay, So here is what you need to turn in, right? So you have to turn in the make file and also turn in your program. All your program means your star.c or star.cpp or star.h, essentially all your program and your make file. And also you have to put the README file to explain how to run your program like a MyBreak or MyHeal.
Okay. So for this case, it will be myheal.c and mybreak.c and the file that we use to compile.
Right. And then make file as well.
What is make file again? Make file.
Make file is let me actually go back here. Okay. So we in the part one, I basically expect students to try to learn how to make file is a facility, is a tool for you to put a few of the Unix command together and try to check the file dependency. So I have a little tutorial. You can see here is a make, and then has a make file tutorial there.
So the make file, the one you posted on the GitHub?
I did post on the GitHub, but you need to you modify that to use that to compile your mybreak.c and myheal.c. I think that make file I posted on the GitHub or whatever I put it was actually compiling homework assignment number 1, part 1. But you need to have a make file to handle your homework assignment number 1, part 2. And if you unfamiliar with Makefile, some of us are already use Makefile in Make or Makefile in the previous courses, but some of you may never experience that. And I did provide the tutorial, but I think sometimes students still don't know what to do with this, and we need to we can actually cover that, and maybe in one of my office hour discussion hour, we can actually show you what to do make files specifically for my break.c and my heal.c, because that's going to be a very simple make file, just compiling 2 programs. I mean, just to let you know that when we compile a bigger program, like when I compile a operating system kernel, my make file is actually compiling at least 50,000 different files. So you can see that the make file is a mechanism that's very powerful to run a very complicated system. But it will be good for you to start writing make file for my heal and my break, which is only like 2 files. Okay.
So we don't, this could be a silly question, but we don't need to turn in any my prefix those numbers, right? Like the printing numbers.
What number?
Like, so if you break it and like you heal it back again, it shows digits, like bytes in a kilo.
No, you don't need to show that. I mean, the way when the TA tests your program, they're going to provide their own test program, and then they will just capture whether 3 things, right? Number 1, the healing process is successful. Number 2 is that those 2 error conditions will be taken care of.
So mismatched and then misplaced.
Right.
Okay.
By the way, I just want to let people know, maybe you can show hand using your Zoom. I mean, how many people have never used Makefile? How many of you? Okay, we have, let me don't finish. I want to just go over there. We have about 50%, almost 40% and 50% never use Makefile. Okay, so maybe with such huge percentage, I probably need to record another section to just talk about the Makefile. Just talk about Makefile, at least you can get homework 1, homework 2 with some Makefile, some basic stuff. Okay. All right, thank you for letting me know. Yeah, it's something which is very, very useful for me as an instructor.
Professor?
Yes.
Where did you post the makefile, the sample? Because somebody said it's on GitHub. And
yeah, I think I put it. Let me actually go to my.
There should be a garlic bulb down there on solo.
Yeah, it's a tar file. I think I put it in this,
all of it
inside here. If you get this one, let's see. If I get this
a lot of
one,
garlic. Bulb. Yeah.
Yeah.
I used
think-
only like for ano.
Yeah.
Whatever you call
It's
solo.
it's
yeah, I saw that, but like, do we need to write a makefile for the MyHero program?
yes, you need to write one for yourself. Yeah, I have my break.c, but you need to write the make file. So let me show you a very quick example. So just make sure that you. Okay, I shouldn't use this window. Okay, that's fine. It's this window.
You didn't go with a lot more colors. Yes.
Okay, this is similar to what you got from the tar ball, the tar file for homework assignment number 1. You see that here I already have a make file. I already have a make file, and this make file is for GCC. Okay, this is a simple make file that's compiling the socket client, socket server, and then you basically using the, so let me actually just change this to a make file that will be my heel or my break. Okay, very quickly to show you a demo. I'm going to make a copy of this to say this is called homework 1 part 2. Okay, make a mistake, sorry. This should be CP, not. Okay, so now I have a make file for homework 1 part 2 that I'm actually using the make file from part 1. Okay, so this is for make file part 2. Now change to full. Okay, so this part is the same. Is I just define my compiler, capital CC as the compiler I'm going to use is GCC, and with some C flag like this, and in this part you can neglect it. I put some other option here, and now here's the rule. The rule, I'm going to put this. Instead of having this, I'm going to do my heel and my break. Okay, I'm going to make this 2 programs. One's called my heel, one's called my break. And then I'm going to do this is my heel.o. I'm going to generate the .o file. No, this is colon. And here I'm going to say my heel.c. And here I'm going to CCC flag my heel.c. And I'm going to copy this and make this to be my break. For those of you probably familiar with the make file, you probably already figured out what I'm doing. And now I'm going to change this to my heel is depend on my heel.o.
Professor, just to clarify,
Mm-hmm.
you want us to compile MyHeal and MyBreak in G++, right? Not GCC?
You can do either way.
Cool, perfect, thank you.
You can do either way, yeah. Yeah, I should probably change this to G++ as well. The only thing is that G++ tend to be more strict in terms of certain kind of type. So I'm just finish this so you can have some idea what I'm doing. Okay, so the clean room, the clean rule is just remove my heel and my break. Okay, so this is essentially a make file for my my heel and my break. I just want to tell you very quickly about what's going on. So I have a two rule. This two rule, they generate what we call object file. I think this is introduced in homework, in lecture number 2 about the concept called separate compilation, about how do you actually compile the code from the .c or .cpp to .o, and how do you actually link them together. This is similar. So I actually compile my heel.o and my heel.o in make. This is called the dependency rule. Means that this side, let me actually write it down. The syntax or make. By the way, if it's this pound sign means it's a comment line. Okay, it's not being read it, so I can put information there. So this is called target, and then you have a colon, and after colon is called dependency file. Okay, could be multiple of them, and then basically is the rule to generate the target. Okay, so this is essentially a rule. Looks like have a 3 element. You can see that my heel.o is a target. My heel.c is the dependency file. Means that you have to have this in order to generate the target. So this is basically checking whether the target, the dependency exists. More importantly, later you will figure out that it's check the timestamp about when was the target generated and when was the dependency generated. And if the target is newer in timestamp than the dependency, then this file won't be triggered because it will not regenerate something which is newer already than the dependency. And then this part is what we call the firing rule, the action, that you are going to execute this command in order to use the dependency to generate the target. So this rule, if you interpret, is basically saying that if my heel.c, the timestamp, the last modification time of my heel.c is newer than the timestamp for my heel.o, then I'm going to fire it up to execute this rule. I'm going to use GCC or G++ compiler to compile my heel.c to regenerate the my heel.o. Okay, that's the rule. And this is the same rule. So basically you can see that now the target is executable, my heel, and the dependency is my heel.o. And my heel.o also the same thing is that if the timestamp of my heel.o is newer than the executable my heel, then I'm going to file this rule to actually regenerate that. Okay, so the top level, the rule is called all rule. So the all rule is going to trigger my heel. And this my heel is going to trigger this rule. And this rule is going to require my heel.o, which will trigger this rule if the timestamp works correctly. And all of this, you can see that at the higher level, you just say make all, and then it will basically trigger the appropriate rule to regenerate all the executable you need to do. Okay, so that's kind of the make files, helping us to manage a fairly complicated programming system with a bunch of files that we need to deal with. Is that give you some high level information for those of you who hasn't used make before?
Make file is just a text file?
It's a text file. Yes, it's a text file.
Okay.
I just want to add to that. If you use Visual Studio Code, that you're essentially translate the concept of the rule into a JSON format. So in WSL, not WSL, Visual Studio Code, when you configure that, if you see the tutorial I provide, it's basically a similar concept, but it's actually using JSON to represent instead of text file. Go ahead. Sorry, I interrupt you.
Yeah, so I have a question about the homework 1, part 2. So in the Word document, like the homework document, you said my break actually generate like another file. Is it right?
Right.
But but in my computer, if I run my file, it doesn't generate another new file.
It generate. I guess what I meant is it generate a lot of chunks.
Yeah, but is the chunk still in the file?
No, the chunks itself, each chunk will have its own. Let me actually show you what you're supposed to see. Okay.
Like
we're using MyBreak to create like several new files.
Yes, MyBreak will do that.
And then, cause like in the code you proved is like we need to write like MyBreak, write several new files. So in the MyHero, are we like write a new file that like combine the information or the content from those several chunk files?
Yes.
Or
I mean,
or we need to combine those chunks in one file. I mean, like for example, like after the my break we have like 10 files, and after MyHero we only have 1 file left, or it's like we should have 11 files left.
11 will be fine. 11 will be fine. If you want to remove all the chunk automatically, that's okay with me. But what I require is that you have that file, the 11. So say you take the original file and you.
And I understand. So actually, like we don't change the original files. We just write like several files that like chunk files, and then we need to write another new file, but the content is
the same
to the file.
Right.
Like, okay.
I actually draw a slide. Some of you might have seen this yesterday.
Also, like for the README file, is that should be a text file or
text file? It's a text file. So I showed this yesterday during the office hour discussion. So essentially, you have an original file this big, and you break into, in this case, 7 chunks, right? So essentially, what you have is a original file. Then you have 7 other chunks. So now you have 8 files. And then you use MyHero. You take that 7 chunks, go back to another file. So in that case, you have 9 files, because you have 1 is original, and then the chunks and the new file. Yeah.
So Professor, it is okay to leave all the chunks there? Like we don't need to delete it? Okay.
No, you don't need to delete it. If you want to delete, that's fine too. Yeah.
Okay, thank you.
Professor, can I like share my screen that it will show it more like straightforward?
Okay. Let me see. Right now we're already 5:17. So right now, if you want to leave for some other things, that's okay. But I just wonder, you want to share the screen? Is it okay for other students to see it?
Yeah, it's okay.
Okay. So Frank, before you do that, I have 2 people already raised their hand for a long time. I want to ask them do they have any question they need to be answered before we go to your screen. Okay. I think Alex and Gabriel, you both raise your hand.
I don't know how to.
I just never put it down. I'm sorry.
That's okay. No problem. I just want to double check. I don't want to, you raise your hand, I never answer your question. Okay, go ahead. It was Frank, right? Who wanted to share the screen? Okay, so let me allow you to share your screen. I think I allow you to share your screen. Okay.
So this is my terminal, and like if I use like my break, to break, can I break this PDF?
Sure.
And can I just do this?
I think so. Should
And
be okay.
my prefix and 8, right?
Yeah, that's 8 kbyte. You break that into 8 kbyte. Yeah, that's fine. That looks fine.
So like I can see this print on my screen, but so the file, this file doesn't actually change. It doesn't create a new file.
No, can you go back to your window? Can you do ls minus L? ls space minus L. You see that? Everything is there.
Oh, what does this do?
That's your chunks. You see that all your chunk is there.
But
it's very strange. Your chunk size is incorrect. It's 8 byte instead of 8 kbyte. Did you modify my break.c?
Little bit.
Yeah, because the chunk size is instead of 8 kbyte, now is 8 byte. So you have a lots of chunks, and the chunks doesn't.
Like I modified here, like original code is like this. It's nothing here. But I don't know.
Can I go up to see your chunk size? How do you define your chunk size?
I didn't change anything here. Just only here. This is only place.
Okay, can you go down a little bit? Yeah, if you use the original, what will happen? Can you actually just use like this? Use the original one?
Okay. So do I need to compile again?
Yeah, you need to compile. You need to hit enter. Okay, just run exactly the same command. Okay, can you do one thing? Can you remove rn, remove the my prefix star. Just remove all the chunks. My prefix star. Just put a star there.
This, right?
Yeah, put a star there. It will remove all the chunks you have, the old chunks. Okay, do a ls again. Do a ls minus L. So wait a minute, you're actually running this on your, can you do a pwd? Pwd. So you're actually running this on your root directory, which is potentially messed up with your other files, okay? So I would suggest you really running this program on a separate folder, so if something goes wrong, it will not affect a lot of things. So why don't you make a directory called homework1, mkdir homework1. Okay, and then cd to homework1. Okay, now we try to just copy cp move, just mv move space dot dot 2 dot slash my break.c and then dot, my break.c and then space dot, space dot.
Okay.
Okay. Now you try to compile that program again.
Wait, what? Why does
no, because we moved to a different place. That's why you have to do it different. But that's okay. We don't need to use that. You can close your editor.
Then do I do GCC?
Yeah, just let's try to recompile it again. Just Control P to the previous command. Yeah, okay, this line, that's good. And then try to run the program again. Okay, let's do an enter. Okay, do a ls minus L. You see that right now you have all the chunks, and may I suggest you to make your window a little bit wider so your line will not be. Yeah, okay, now you can see that everything is in here, and you have 15 chunks, and all of them except the last one has 8 KB, 8192, right?
Yeah.
So that's the way the program is supposed to work.
Okay. Yeah. So thank you, Professor.
Okay, so figure out. I mean, what you change, it might be, you might want to do something which is good, but there's something you need to consider more carefully when you change it, and then figure out why, and then you can actually develop your my heel from there. Okay.
Okay. Thank you.
Okay.
So if I do my heel, do I do like on this? Can I do my heel on this same file?
Yeah, you should do in the same directory.
Okay. Thank you.
Yeah. You're welcome.
I'll stop sharing.
Okay. Thank you.
Sorry, could I ask a question?
Sure.
So I'm trying to get VS Code to work with WSL. But because like my Linux distribution is in a hard disk image file, I'm not sure how to get VS Code to like look inside the hard disk image file. Is that possible, or?
I mean, I'll just be asking you to read something. It's not any like serious. You know what I mean?
Oh, I see what you're getting at. You're saying that
I can share my screen, but yeah.
Sure. Why don't you share your screen?
So like this is my Linux distribution, and then under local state, it's just a it's just a hard disk image file, and I can't actually access it. Or here I can try to.
Sorry, what is ext4 VHDX? It's a virtual machine, right?
Yeah, I think it's a hard disk image file.
But how do you create a hard disk image file?
I don't know. It just created itself when I installed Ubuntu.
Okay. By the way, how do you actually install Ubuntu?
Oh, I went onto Windows and then got Ubuntu 18.04, I think.
Did you install that from your WSL installation, or you actually installed it separately?
I don't know. I went onto the Microsoft Store and installed it from there.
Okay. So let me just clarify a few things. Is that what WSL has is not really a full Ubuntu operating system. It's a subset of the environment that's actually give you the same Ubuntu, but it's not 100%. It's a stripped down version, which is enough for us to do development, but it doesn't give you everything. And therefore, in that installation process, the file system will not need to go through that process like what you have. But however, I'm worried that you got that disk image because you install separately another full-fledged Linux operating system. Which it's not saying you cannot access inside the file, but you need to do extra work to get it to work. I will suggest you to at least to start with, let's not get into that trouble first. Let's try to follow the step-by-step installation for WSL, and which I included in the syllabus, and see if you can access to the file. If you still have problem, I'll be happy to take a look at the you see that I actually see you have a WSL Ubuntu, but inside there is a hard disk. That's actually somewhat
yeah, because I thought I did follow the instructions, but maybe I missed a step. So I'll just go work through everything again, maybe.
Okay, just go through everything once more. And I have a video which also show that the step-by-step and then what you can try. If you see any point is deviate from what has been shown, let me know. I can actually share screen, make appointment with you, and maybe have a special session for all of you, not just you, but others who would like to use WSL. Okay.
Okay.
All right.
Okay. Thank you.
You're welcome. Okay. Any other question?
I have a problem.
Okay, go ahead.
So like I just download the VS Code and can I share my screen to you?
Sure.
Okay. So here it says like you have Windows system for Linux installed on your system. It says, do you want to install the recommended extensions for it? So I don't know, like I should choose show recommendations or install for, because I already have the WSL like for ecs36b.
I forgot what I did. But I think it's okay for you to install. It's not going to change anything. Yeah.
So just to install.
Yeah, you can install that. That's okay.
Okay. What?
I think you already installed. You already installed. It says it's already installed. WSL already installed. Yeah.
Okay. Because like what I usually do for ecs36b is I use the problem text to write my code, and I have Ubuntu. Then I run my program on the terminal. The Ubuntu prove to me is if that is work for this class.
Yeah, that will work. That will work as well. You
okay,
can actually run on the Ubuntu
but actually,
terminal.
It seems like the VS Code have a terminal inside. So,
okay, you have to be careful that the terminal inside VS Code is not exactly like Ubuntu window, and you have to go to that window to run a command. It will pop up a Ubuntu window, a Ubuntu terminal for you. And then you can develop that. So the terminal in VS Code is basically really just showing the input-output from your SQ, the program. But if you want to a terminal, then you have to, I forgot the command, like a run, it will pop up a Ubuntu terminal for you. And then you can do makefile, whatever, over there as well.
So actually, I can just directly like write code through a VS Code or Sublime Text, and then use my Ubuntu terminal to run the program.
Sure, you can do that.
Okay.
Yes.
So the terminal in VS Code is not
It's
real
different.
terminal.
It's not a real terminal. It's not a real terminal as a Unix terminal. It's just a terminal for VS Code.
Okay.
Okay.
Professor?
Yes, go ahead.
So in relation to the question from, I think it was, I think the solution to that would be going to WSL, to the command line, and opening the code or the file with the code command from the command line. Instead of going to VS Code and trying to find the directory, maybe starting from the command line and trying to open the code from there.
No, I mean, I can do that. I just want to, I want to be able to use VS Code because I want to use the VS Code debugger and stuff. So
right. I mean,
see if it's possible.
What I mean. That's what I mean. If you're on the command line and you do the code command, it's literally code and the name of the file. The command line will open VS Code with a file. Yeah.
Okay.
Okay.
That sounds reasonable. Yeah. Thank you.
Thank you. Yeah.
Okay. Any other questions before
Professor?
Go ahead, please.
I have a question about a VSID. I don't know why, but I cannot get the VSID from the client file. It shows ID not found.
Okay. There are two possibilities that you might be new to add it to the class, or maybe at the time when I download the file, your student record is not in the master file. So why don't you send me an email, because I don't want you to reveal your ID information, and I will check. I will check from my side, okay? And then to see if you are missing them, we'll figure out how to add it back to the system.
Okay, thank you.
Thank you. All right, any other question?
Yeah, Professor.
Go ahead, Gabriel.
I have I guess a pretty simple question. I'm trying to append a integer to the end of a string, and I can't figure out how to do that in C.
You want to append integer to the end of the string.
Like for homework 1, for example, like at the end of the name of the broken files, it's like 0000001.
Right.
Like I want to add the 1 to the end of all the zeros.
So let me see. Let me actually just check on this very quickly. If I go. So here is how I append. I don't know whether this makes sense. You see, I actually append an integer to the string this way, right? This line.
Yeah, but I don't want to print the name. I want to use the name to open the file, which is why I'm kind of confused.
No, I use sprintf, not printf. I use S.
Oh,
did you notice that I use S? S means it's printing to a string. So in fact, I explained this yesterday in the office hour, that fname is a string. It's a string buffer, right? I use malloc to create. And I set it to 0, and then sprint means that I print the whole string, which is with the prefix and notice that this is format string is kind of tricky, because usually we just print with %d, right? %d will just print the integer, but that's not what I want. I want to print the fixed format. I want to print 32 of them, and also I add another 0 here. That means it will fill in with all the 0. So it will nicely come up with that name. So that's why if you look at this line, sprintf is a string printing to a string buffer.
What buffer does it print it to? Like, does it assign it to a variable or?
Yeah, assign the first argument, fname.
Oh, okay, that's okay.
See that's the destination. Yeah.
Oh, I thought Okay, so can you explain to me the percent 032D again? Like, why is it 32?
Okay, so let me put it here. Okay, explain. I'm going to explain percent, the difference between percent D, percent 32D, and the percent 032D. Okay, there's another one actually. I think it's percent minus 32D. Okay, there's a 4 format. So percent D is just printing regular. You have been using that, right? So percent 32D means that it's going to print an integer, but it's going to occupy 32 character. So so it's going to be something like this. Let me actually show it to you. If it's percent D, it's just print out a number 1, 2, 3. If it's a 32D, it's going to print, I think it's going to be a lot of space, 32 space, whatever, 123. It's totally the 32 character. Looks like this. And percent 32D is going to print 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 2, 3.
So the 0 tells it what to fill that space in with?
Yes.
Like, could you change that to like a dash or anything? Or does it have to be 0?
I don't think so. It has to be 0. I think it has to be 0.
Okay.
It can only be filled up with 0. I don't know. I never, believe me, I never tried that. put the dash. The minus is actually doing this. Is 1, 2, 3, and then have all the space. So let me actually tell you that this is. Let me use a bracket to say the whole space is printed. Okay.
Okay. Yeah.
It's actually
I
this 1, 2, 3, 4. Yeah. So this is like a format string that for you to play around. Okay.
Yeah, thank you. That helps a lot.
Okay, you're welcome. Okay, any other question?
Hello, hello. Hello? Oh, you can hear me.
Go ahead, Simon.
So when I try to do the my break, or when I try to run the my break, it only creates one chunk no matter what I do.
Are you did you modify you create your own program, or did you modify my program?
I use your code.
That shouldn't be the case. How do you want to share your screen to see what happened?
Yeah. Is right? All right. So basically, I just you compile it, and then I don't know what this error is, but I don't know how to fix this.
That's a warning.
Right.
That should be okay. Yeah, go ahead.
All right, so then I'll just use 8. It only creates one chunk because the file is like 10 megabytes, but it only creates one chunk.
Can you do ls-l file.pdf?
ls-l
space file.pdf. Yeah, it's 8K byte. It shouldn't just generate. Can you do ls-l? Yeah, even that chunk is only 493 bytes. File.pdf. Interesting. Interesting. Let me see what happened. Can I look at your mybreak.c Emacs? Go into your mybreak.c. I want to check what you. Are you sure you didn't change anything, right?
I didn't change anything. I did a fresh copy paste from the link you have on Facebook, and it does the same thing.
I'm looking at your code right now. Just hold on 1 second. Can you, on this window, sorry, on the Unix terminal, can you do a man B0?
A what?
Which is MAN, do a MAN space B0, B0, ZRO. Yeah, enter.
Oh.
So you cannot see what B0 looks like. What is the operating system? You don't have a man?
No, this is the Windows 10.
Wait a minute. Are you using WSL or what kind of development
this
environment?
This is a bash because it worked for me when I used it, but I have WSL set up here, but it wasn't working, so I was using bash.
Yeah, they might have some incompatibility between the window part, some of the system call. Now, because I'm using Unix system call for my break, and it might have some incompatibility there. So I'm familiar with your development environment, but can you try to see if you will experience the same thing with a Linux or with CSIF? And then we will be able to see is whether it's your program's problem or it's actually environment mismatched.
All right.
Okay.
All right. I'm gonna try doing that.
Because, for example, the B0, if it's not supported, we want to make sure that the behavior, those system call, function call are exactly match what we have. Okay.
Yep.
All right. Right. Any other question? Okay. So I will end this one and then upload the video. Just want to make sure that you know that we have an office hour tomorrow afternoon, 1:40. If you have a question, please just bring it there. And then Friday, we're going to talk about final project. Okay. All right. Bye.